Today, this image actually is showing it, but we're going to talk about a product we've been producing for quite some time, 4700 series from Rayhow. It's a hybrid product that's composite between fiberglass and uPVC. This is a project we did in Washington a number of years ago. It's actually a university in Spokane, Washington, and huge openings. Very proud of it. It was a passive house project. All the manufacturing was done here, and we shipped all the products down, and just a stunning photo. So I just love to kind of start with that. We've called our presentation Architectural Marvel. This window we've been producing, as I mentioned, for a number of years, but it just has, I think it has a lot of legs, and Rayhow did a great job developing it. We were part of the development of the product, so I'm going to talk a little bit about that, and we'll get into some details. Alfred, the two of us, I'll speak a bit about the product itself, and then Alfred's going to talk about how we use it and some projects that we've been installing recently. I think you'll get a lot out of it. So first, I'll start with us at Euroline. I mean, it's 30 years now we've been in business. Energy consumption, carbon impact, all the bullet points that we have here are things we think about a lot. I was at a building show in Toronto last week, and very topical, how buildings contribute to greenhouse gas emissions in all of our cities. And so a lot of cities like Toronto are thinking more about building better buildings. We're very fortunate here in BC, where we're located. It's topical all the time. Our building code is advanced. And, as a window manufacturer, we love that, because the only thing we want to do is produce the highest performing windows we can. And the conversation is easy here. The conversation is a little more difficult in other markets. It was a little more difficult last week in Ontario. However, people are interested. And so that's a great thing. And I think this mindset of sustainability and trying to build better buildings is something that certainly we applaud, and we're looking forward to doing more of. So high performance fenestration, that's the root of our business. Today, it's like this crazy cross-section of architectural requirements, really huge openings, but still at the same time building the best fenestration from a thermal perspective that's possible. That can be challenged because uPVC does have limits. And so what we found in the 4700 is a product that we can make really, really large without the need for much reinforcement. In the terms of steel, because the actual product itself provides enough reinforcement from within. And I'll get into that in a few seconds here. So the material RoughEPro, kind of like this graphic or this image suggests, it's a fiberglass core. And around the outside of the core is PVC. And because it's blended together, we get the best of both worlds. We get the ability to manufacture a window like we would a typical uPVC window, meaning we can weld it. We can weld the thing together. We get a very smooth surface that we can finish. We happen to foil the outside of our windows, but we still get all the strength of fiberglass. And so that allows us to build a unit that is extremely strong. So in order to get it to work here in North America, we had to make some modifications. And the three images that I'm showing here, I wanted to try and highlight the North American modifications to this system, because it was originally introduced in Europe. And these are Euroline modifications. On the left, we've created a groove in the profile. And you can see where I'm showing a connection where two window frames are connected together. This groove here allows us to attach things to the window frame. In this instance, we're putting a connection strip on, but you can imagine a brick mold could be installed through here. You can imagine some sort of a flashing detail. All of these things attaching it to the window to allow us to get the weatherproofing that we want without having to connect underneath, and it makes it a lot easier to finish. So that's sort of an adaptation we had to make, and Rayhow was happy to make it, because it made sense here in North America for the construction methodologies that we wanted to employ. The next thing I talked about earlier is the weldability. So because it's a uPVC blend, we can weld. It's not mechanically fastened. So we can get a permanent closure and a significant amount of strength into the corners. And so the middle image is showing a weld. And then on the far side, on the far right, what I'm trying to illustrate, two items. One, a nail flange. The nail flange on our profile is co-extruded. So of course, for passive house applications, it can be cut off either in the shop or it can be scored and snapped off on site. But having the ability and the flexibility to come out of the factory with a nail flange, we find certainly for North American installations, very helpful. And then the strap anchor, having to sort of modify, because we're doing wood frame construction, having the ability to incorporate a strap anchor into the design was pretty critical. So all of these adaptations were made some 10 years ago between Rayhow and Euroline. And it was a matter of trying to introduce a European product into really the Canadian and US markets. The next thing that we did, one additional piece, has to do with our door systems. And we're going to talk about our door systems in some of the projects that we're working on, at least Alfred is. But the standard sill is what you see on the left. So typical frame, this is a little over 3 inches tall. The challenge we found with this was in a door, that's a pretty high step over. So what ends up happening is often in most window systems, you'll end up on the far right with a barrier-free sill. So a much lower step over, you can see here's the frame and here's the sash. The problem is you're only getting one gasket protection. And that to us just isn't enough. And so we spoke to Rayhow and they were able to develop for us, or we co-developed a much lower sill. This tends to be our typical door installation. It's a little over 2 inches. So it's a much lower step over, but you still get the benefit of receiving 3 gasket protection. So kind of a cool modification to make. Okay. Benefits of RAFIPRO as a material. Because it's a fiberglass / PVC composite, the profile doesn't expand near as much as just straight PVC. 40% less profile expansion according to Rayhow. That allows us to do much larger windows, not only because of strength, but because we're not going to get the expansion from heating and cooling. And most of the projects, let's face it, we're doing are colored. I guess traditionally white would have been the color of choice for anything that was PVC, but today that's just not the case. More than 50% of what we sell is black. And so black will attract a lot more heat. You're going to be exposed to a lot more expansion and contraction. So the benefit of the RAFIPRO in the core is that we get less of that. And so our concern for warpage goes down significantly. And consequently, we can build much larger windows and in passive house applications without the need for reinforcement. So that's a huge benefit. Really quickly, on the system itself, it's a 6-chamber system, 3 gaskets, as I mentioned. We can fit a very large IGU into the glazing cavity, 52 millimeters. Many of the passive house projects we're doing triple glazing. A 52 millimeter IGU is not that simple for most systems to accommodate, but ours can. And so we can get pretty significant thermal performance out of that. One of the things we'll talk about, I mean, this particular image doesn't have any reinforcement in it. When we get into passive house applications, you're putting foam in most of these cavities, so there's not a lot of room for reinforcement. The 52 millimeter glazing that I mentioned, we also in a passive house application changed this center gasket. You can see now there's some actual air cavities in the gasket. All of these very small modifications improve the performance of the window. And this is a certified component, both the window and the door. And then we kind of take it from there. We can make windows. Of course, we can make swing doors, and we can make tilt and glide doors. What does that mean for a project? It means anything that you're going to require, we can make out of the same component. And then on the door side, just to kind of like give maybe some peace of mind, you know, doors can be 7.5, 8 feet tall on projects these days. With no steel, it is still a PVC hybrid window. We do have a little bit of concern at times around warpage. The way we get around that is we do put very small pieces of steel inside, and this is all disclosed when we're working on a project, right? So everybody knows what's going on. The rest of the window frame and sash would have foam in it, but these small amounts of steel, 6 inches, they're put in where the hinges are located and where the handle and the catch are, and that's it. The rest of the window can be installed, and this is just in the case of a door, right, where it's quite large. Windows themselves won't have steel in them. So when Alfred and I were putting this presentation together, we are working on 2 multifamily projects right now with this material. And Alfred wanted to go into some of the details on how we've done that. So I'm going to turn it over to him. And then at the end, we can come back and answer any questions you might have. Yeah. Okay, go for it, Alfred. So.
All right. So I have this fantastic tool to work with the rauFibro. It's a very strong, very adaptable product, as David mentioned, for frame all the way around for all the systems. So it's easy to connect different types of components to each other, and it makes it easier to input data into the PHPP. We know that the window part of the PHPP is very complex, and I think that we feel it's very important for your window supplier to not just be a window supplier, but to have a really good understanding of the importance of that data, the importance of that third decimal point, and how it all adds up in the PHPP to the overall energy consumption of the building. So we are very detail oriented about that data. We really look into each project, and every single window configuration and how it can be optimized and how we can engineer it properly to work well with the model. So the image there is a project we're working on currently. As you can see, that was a few weeks ago. All of the windows are now installed in this project. And from a quick glance, it looks like pretty straightforward. We see some punched openings, which is really ideal for a passive house. We have a pretty consistent sizing there, and those are all easy to produce with foam in them and to the certified sort of performance numbers. So, but they're not all of that straightforward. If we go to the next slide, we're going to look into the nitty-gritty of this and to look at, as we're talking about optimizing design for performance, and also, what we can say is the elephant in the room. So what we see on a certificate is not necessarily what you're going to get in a real life application on the site. Because once an engineer looks at a project, it's not as simple as taking 2 passive house components and screwing them together and going with that data as you see on the certificate. So if you look at the image on the left, you see a tall door with a short side light. The image on the right is a small window with a large direct glazed side light. Now, those are both exactly the same sized openings, but with the 2 different configurations, you get actually 2 completely different performance options. If we go to the next slide, we're going to look at lots of Flixo models in a few minutes, but this is just a good example of designing an optimal performance option. So on the left, we see that image that we just showed you as built. So it's a 90-inch tall door. So that exceeds the optimal height for rauFibro without needing steel reinforcement. And at that height, so that we can provide also not just initial quality, but longevity, Rayhouse enforces, and the engineer will enforce, that we put steel in a continuous way. So the blue line represents continuous steel inside the sash only, not in the frame. And the green line represents a type 2 connection. So again, it's not just a matter of screwing 2 certified products together, because once you get over certain heights in the building, you need a stronger connection. So that type 2 connection is not really problematic. It's easy for us to meet the FRSI values, all of those things for comfort criteria. But when we have steel in the door, we have a less than ideal option. So if we go to the next slide, we can look at our certified door sash. So if you look to the performance number there, it's 0.743, which is fantastic. Actually, with this rauFibro system, it's interesting because the more frame material you add, in a situation like this, you actually get better frame value performance because the frame performs so well. It's very low conductivity. If we go to the next slide, we can see a Flixo model of a picture window. So that's what we have in those two images that we showed you. So great, we got 0.743 plus 0.697 plus some high performance glass, ergo performance excelente. But if you look at what you've actually got in this next Flixo model, so we'll just stop there for a second. So when the door exceeds, as we mentioned, when the door exceeds the height, we have the steel and the sash. So if we compare that picket, we see that performance number with the type 2 connection, all the foam almost all gone from that vertical in the sash. Our performance number is suddenly 1.27. It's still okay as far as comfort criteria. It's still okay, FRSI, all of those things. You can see in the isotherms, though, that you got a lot more green towards the interior of the frame. But as we know in the PHPP, we add those components up in lineal lengths. So we have a less than ideal situation there, but we at least are able to provide the correct data that can be added into the PHPP. So if we go to the next slide and we go back to this example, that same design configuration could have been much better if the door was slightly shorter, slightly wider, or if we would have gone with the small picture, operable picture, and the big side light. I believe that's the next slide. Yeah, so if we look at the option on the right, the operable sash in the window will still have foam continuously throughout it. So the only problematic area would be a type 2 connection in the vertical between the side light and the window sash. And again, we know that the area of glass is important for calculation of the model and the consumption of energy. So this is not a compromise. And in this type of building, it's not a compromise for any kind of accessibility or anything, because those doors go nowhere. So that would be the best solution, would be to design for optimal usage of the products and how they work. So the solution really would be to either change the size, change the configuration. What we accomplished on this project, because we did have this design already in place, this is the way it was going to be built. Once we got the engineer to have a look at it and he obligated us to use more steel than is ideal, then, as David mentioned, we have that ace in the hole by being able to use thicker IGUs. That thicker IGU adds a lot of performance to the overall system. And we put that in the entire project. So the 52 mil glass improved the performance of the entire project, even the windows and picture windows that had full foam in the frames or foam in the frames and sashes. So that made a huge difference, and it more than made up for those weak links.
No cost implication.
And exactly, David is saying there's no cost implication to thickening that glass. So it's really a great option when you're using that Ralphie Pro 4700 series product. And the one thing that we didn't do, and I'm going to mention it again later, is we didn't cheat the system by trying to use higher solar heat gain. Please don't ever do that. Solar heat gain is not your friend. It's like cheating on your taxes. It's not going to give you a good result. It'll end up with discomfort for your residents and a bad place to live.
You'll pay for it eventually.
So we're talking about passive house components today, and this is an exciting component that we actually developed for this project. So this is a Juliet balcony. So this is one of those tall doors that actually goes nowhere. So they needed a thermal bridge-free Juliet balcony solution. So they didn't want to bolt a Juliet to the structure of the building and have point thermal bridges. We saw that excellent presentation by Ed May yesterday talking about thermal bridging and how problematic and how that all adds up to a poor performance in the building. So this is, we go to the next slide, we can look at our Flixo model. So as you see in the image, it's a very sleek looking system. You can still see the windows and doors will all look the same from outside because you're just looking through glass. You just see those standoffs. So you see the Flixo model here. Now this is a chi value of that point thermal bridge. So right at the standoff point, that is your value. And it's in that same sort of problematic door sash window combination where you have steel in the door sash. But again, this is the data we provided, and the data was acceptable. And the Juliet balconies really work well, and we're able to install those after the finishing of the project. So there's no worry about them being damaged. They're really tight, and we're pretty proud of that detail. So this is a second project that we're working on. Ironically, we're doing our first delivery here this morning. So windows are being delivered to this project in Vancouver as well as we speak. So there are different challenges on this building. As you can see, the window configurations are completely different. There are a lot of windows with a picture beside an operable vent, which is a much better combination. Mm-hmm. We didn't have the same kind of challenges of steel in our products on this job, but the building itself had some challenges. As you can see, there's some steel balcony connections there, no comment. And that resulted in the next slide. Lots of insulation. Now, this is not because of the windows performing poorly. This is because of the overall model. And so when we are helping with design, we want to help the builder, developer, or homeowner avoid a situation where they're doing this, where you're adding a foot of insulation to the outside mm-hmm. to make up for other things. Because, I mean, you are dealing with giving up real estate when you're adding a foot to the outside of the building. And in a single family residential project, that's definitely not ideal. Speaking of single family, we have another example of designing for optimal use of the building. So this is in East Vancouver. This is a north-facing Windows 700 series. Now in single family, it's nice because we often have a lot more input into the design when we're talking to the architect or the passive house designer. This was originally drawn as a fully connected window system. Now, we had the ability to do that with big steel connections, but that would have made a pretty cold window system. So what I proposed with the designer was to put a wood element in between all of the windows, as you can see, but that wouldn't have been strong enough. So once the engineer looked at it, we see that we ended up with some really, really thick walls there. I think it's about 20 inches from the face of drywall to the window frame. That's not all just insulation. What they did was a steel superstructure that was the support for the building to hold the building up. That's just inboard there at the drywall. And then there's a lightweight wood structure that's all insulated. That's just supporting the glazing. So that resulted in these big 13-foot windows being able to be the picture window element to be just foam filled with a small block of steel in each corner to support the glass. And then a small operable sash, which is again so this is fully Passive House certified product. There's not really any input into the Flixo model because it's incremental steel is irrelevant. And so these perform super well. So this is a really nice looking house. It's a true Passive House classic as well. So as I mentioned, it's all 4700 series. The windows, even the entry doors and the sliding systems are all 4700 series. So this house has really high ceilings, as you can see from that inside image, but it's Passive House classic. There's no additional ventilation system. So there's no additional heat or cooling. And it's nice and warm in the winter, nice and cool in the summer. And the homeowners are enjoying it a lot. So just to wrap up then, the point that I wanted to get across is that we understand the importance of this data and we are able to provide the data. We have Flixo models on basically every conceivable component connection. And we are very thorough with that data, and we have a really good understanding of how it all plays out into the performance of the building. But ideally, we would want to design for optimal use of the products. So as you can see from a couple of those examples we showed, it's a pretty small tweak to get that same window system to have no steel at all in it, which works better and looks exactly the same. So the conversation, that's what we love about this Passive House community, is the conversation is always open to improvement, and we're here to help with that. And again, little sidebar to Zach and the Accelerator crew. We need a T-shirt that says "Don't use solar heat gain to cheat the PHPP, please."
Alfred and David, that was fantastic. Thank you. And so great to see how your design thinking and kind of data analysis will allow folks to optimize their work. So that kind of overall systems thinking and understanding of the building and the implications of these sometimes very small design choices. I think is super, super valuable. So thanks for those examples. And we got some great questions. So let's dive into those. I think the first question we have is from Tyler Board. Let's see, Tyler, are you here? If so, can you unmute yourself and ask your question?
Sure. Yeah. Thank you for the time and question. My question is, do you foil your own material in-house, or do you purchase that material already foiled from your supplier?
We foil it all ourselves. We use Sky foils, manufactured by Continental, and yeah, we do it all here.
Great. Thank you.
Yeah, you're welcome.
Great. Thanks, Tyler. Next up is Jeff Betts.
I just had just a question about like a couple options with the system. The first one is, do you like the drainage holes to the front? I know you have the detail like shown in the door where you can do drainage to the bottom. I assume that's applicable for the tilt turn. I'm just wondering if that's still applicable with that cool profile you guys put around the perimeter.
Yeah, all the drainage is going to be to the exterior. Yeah.
Oh no, I mean straight down versus out and with the little cover caps. You know what I mean? Like, so like concealing it on a tilt turn.
Yeah,
versus...
no, you're right though. It is with cover caps. Everything's going to be draining out the front.
Got it. And just one quick question. The is there concealed hardware available for tilt turns at the interior?
It's difficult to source, I would say to you. So, maybe the short answer is we're open to it, but it's not something that we have really used very often. No.
Got it. Thank you.
Yep, no problem.
Thanks, Jeff. Up next is Vitor. I don't know if I'm pronouncing that correctly. Vitor?
Yeah, that's correct. Thank you.
Okay, great. Thanks for being here.
Yeah, so I see that you have a PHI certificate already for these 4700 series.
Correct.
And I see that you have a field certificate for the 1800 series for the Euroline. Is there any plans to certify these 4700 series for fields as well?
We certainly could. Would there be, I think it's sort of like from a business point of view, we would say we've already got proven capability with the PHI certificate. So it's kind of like, do we want to move farther or not? We're open to it.
Okay. No, it's just because it gets easier to document everything, right, for PS projects. But for sure, you have all the AMA documentation.
Yeah, like what I would say is, what we find is that's just an entry into the conversation, and we're going to provide you with all the information you're going to need for your modeling. And it's a lot of it in our experience happens at the project level, right? Like really working it out with the consultants. So the certificates are helpful to get you into the conversation, but really it's like, do you have the data and can you back it up? Everyone's going to verify and validate it in our experience.
Great. Awesome. Thank you very much.
Yeah, no problem.
All right, thank you. Next up is Lindsay Klein, and Lindsay, I know that this may have been answered in the chat, but I think it'd be great to bring the question to the full floor here.
Was this the delivery time question, Zach?
I think it was a combination. It was where are your doors and windows assembled, and what is the typical lead time?
Yeah,
in the US, specifically for her in the NYC region. Yeah,
so we manufacture all of our products here in Delta, BC, just south of Vancouver. We ship anywhere in Canada and the US. We can get product to you within 8 weeks. we manufacture pretty quickly because, you know, one of the questions earlier, do you foil? Yes, we do. We control the entire manufacturing process. Profiles come from Europe, but we keep them here. Like we bring lots of stock in. So 8 weeks is our guaranteed lead time to any project in US or Canada.
Excellent. Thank you. Next up is Jason Wen. It looks like maybe Jason has left though. So I will, unless you pipe up, Jason, I'm going to ask a question for you. And that is, for the barrier-free door sill, how is that threshold secured in place?
We we actually weld it. Yeah. Like to the frame itself, it's welded. Yeah.
Great. Cool.
It's not mechanically connected. Yeah.
Excellent. All right. Next up, Joshua Van Wyck.
Thanks, Zach. Hey,
Yeah,
David.
thanks.
Hi, Alfred. Thank you for the great presentation and for highlighting one of our projects. Great to see. And excited to see those windows coming to site today. I would just, you know, maybe put a little plug in for you guys, which is that you are really great to work with. I think very collaborative, and you know, the barrier-free sill as an example, I think in the ones that you're delivering to us, you figured out a way to put a second gasket on there to make it a little bit more airtight. So that's pretty just kind of neat. One question I had is just whether you guys are expecting to update your passive house certificate, because I think right now it doesn't include some of those other door sills, and I know with the PHPP 10 they ask us to put all of that in right from day one. So just wanted to see where you guys were at with that thinking.
Yeah, I think that's a great question. That is something that we are interested in doing. The door itself was something that we just recently updated. I think it was maybe with reference to your project. We wanted to make sure we had that done. So yeah, I guess the short answer would be yes.
Awesome. Yeah, and I guess the final plug I'd put out for you is the availability of the Flixos and the Therm files that you guys provide has been incredibly helpful to our project. So I think, you know, that idea of collaboration is really key, and a learning from me on this project is that it would have been great to get you guys in earlier in our design phase, right? Which is sometimes a challenge from a purchasing perspective, I guess.
Yeah.
You know, and I don't know if you have any suggestions on how to engage you earlier on in the process before bidding has actually, or tender has actually occurred.
Yeah, no, I mean, first of all, Josh, thanks very much for the plug, and you guys have also been great to work with. We are equally excited to get you your windows and see how that project comes together. I think, Alfred, do you want to chime in on this? Because I think that's a good question about how to engage earlier.
Yeah, and thanks, Josh, again. And it was nice collaborating with you as well. And we had some good conversations about how to overcome these typical types of details. And I think that what's key, and we're working on this right now, is doing a series of lunch and learns with some of the principal designers. I mean, everybody in the audience understands how this all works, but they may not understand what the small intricate limitations are of certain products, which are not really big barriers. There, as you saw in the example that I showed, it's just a quick tweak. And you know, if the designer knew, oh, if I make this window or this door sash 3 inches shorter, it's going to really affect everything and make everybody's life so much easier. So I mean, we are working on that. A lot of the designers we work with are already very familiar with our products, which you are now as well. So going forward, I think that's key. And like you say, sometimes it got too late. Like with your project, we were doing shop drawings, and it would, you know, it caused everybody to have to do a bunch of work in the last couple of weeks there that could have been saved earlier. So we're working on it. I think that it really is about everybody knowing, being aware of it. So we're all about trying to provide that information.
Yeah.
Awesome. Thank you.
Great. Thank you, Joshua. Next up is Bernard Flaman.
Hello. Thanks very much for the presentation. The work is obviously very detailed, and it's interesting to see. My question was about life cycle. A lot of discussion in life cycle analysis lately is shooting for a 50-year target. And I think, as we all know, it's the insulated glass units that are often the Achilles heel in that kind of time span. And I was wondering if there's a level of repairability in relation to these windows. As we know, contemporary windows are so kind of tightly glued together and sealed together. And, could you, for example, swap out an insulated glass unit and have the frame and the sash continue on for maybe another 30 years or something like that? And I'll add one more comment. It's the whole black trend as well, which has me really worried in relation to climate change resilience. And I wish my colleagues in the architectural profession would think this through a little bit better.
Yeah.
Thank you.
Yeah, no, great question. Our system is a dry glaze system. So you can absolutely swap out an IGU if it were to reach end of life and fog. Then yes, you could just simply, they're all glazed from the interior. The glazing stops pop out, replace the IGU, can even replace the glazing stops if necessary, if some of the rubber was failing, and you're good to go. Yeah. Oh,
Excellent.
Zach.
Great question. Yeah, I muted myself.
No worries.
Awesome. So next up is Patrick Fitch. Make sure he's still here.
Yeah, sorry. I was just wondering, for tilt and turns there, do you guys have your own screens that are available
Yeah.
on the interior, or
Yeah,
is it
so
like a second
Yeah.
party, or
it's a second party we use. Flex Screen is their name. It's a hardened steel bar that fits inside the actual frame and sash, and then the sash closes against it. It's a great product. We've been using it for about 3 years. Prior to that, and we can still do this, we can make a traditional aluminum bar screen that also attaches itself to the exterior of the frame, but we're not it doesn't look as good, frankly, and the clips are kind of finicky for turn screens if you're familiar with them. So we use a flex screen. You can look them up too online. Yep.
okay, good, thanks.
Yeah, good question. Thanks.
Yeah, thanks, Patrick. Next up is Sandra Roller. Hey, Sandra.
Hi, Zach. Hi, everyone. Thanks, David and Alfred, for a great presentation. My question is about the simulated center of glass performance values. Since I saw you offer a 52 millimeter glazing space as opposed to the typical 46 millimeters. And I find that recently we sometimes have challenges with the 46. So I'm really just wondering if you have and I'm pretty sure you do, a table of performance values that you can provide.
Yes, we do. I'd be happy to share that with you today. I'll email them to you. We have it simulated in Window, and we get some really good numbers.
Yeah.
We used, Joshua asked for that same data, and for the Denmark project that we're working on in Vancouver. So yeah, I'll share that with you today.
Great, thanks.
They're really good. Yeah.
Fantastic.
Yep.
Thanks, Sandra.
Yep.
Okay.
Guys.
Yeah, absolutely. Let's see. Next up is Boyd Buck. And I see Boyd in the list here. All right. Boyd, I see you're unmuted. You want to ask your question? I can ask it for you if you're having technical problems. Looks like you might be. So let me ask it for you. So Boyd asks, are there plans to offer a tilt turn in the 1800 series?
No, I mean, the series itself, we've numbered them. Don't really actually know the history of it, but that's a whole different frame system. That's 100% PVC. Interestingly, we have developed a fiberglass Rafi Pro sash for the 1800 casement. But yeah, no plans to make that a tilt and turn. Wouldn't need to really, because the tilt and turn covers what it needs to. Maybe we missed the premise of the question. I don't know, but yeah.
Yeah, Boyd, if you have a follow-up, please feel free to type it in the chat, and we can circle back. We've got one more question, so I just want to let people know that if you have a question that you'd like to ask, now is the time. Please share it in chat, and we can get to it. Now let's move on to Jeff Eckes. Jeff, you have a question.
Yeah, I mean, got here a little bit late, but I got onto your website and I see your Resi windows. First thing I see there are some windows that have a rectangular format longer than they are taller. And I've tried this with a few different manufacturers and they've all refused to build them. Do you guys build a tilt turn that's wider than it is taller?
We can in a small format.
Yeah.
Say sometimes we'll use them for like an egress window. So if it's within reason. For example, you could do a 30-inch wide by 24-inch tall tilt turn window.
Yeah.
But it would have a warranty restriction on it.
It's the sagging, right? We're just a bit concerned about the sagging against the hinge, but we can certainly look at anything and give you a comment on it and you know what we could do. Project specific, of course. So yeah,
I do these over beds a lot in bedrooms
Gotcha.
for privacy. And I've been, relegated into doing 3 smaller ones rather than 2 wider ones.
You want
which
it open for cleaning? Is that what I'm guessing? That's the only purpose to kind of open a window like that.
correct.
Yeah,
Correct.
yeah.
Although, don't put it past the client. If you've got a screen on it and it's springtime, they may just throw the windows open and let the breeze go through the house. It's upstate New York. Everybody likes the fresh air, et cetera, et cetera. If there's a warranty restriction on it, I'd probably avoid it.
Yeah, I get you. Fair enough. Look, we're happy to look at it, right? If you had a dimension set you wanted to throw us an email on, we could respond to you and let you know what we can do.
I got 2 quotes. I'll put you guys on the list.
Sounds great. Appreciate it, Jeff.
Thank
Thanks.
you. Thank you.
Thanks, Jeff. We've got a follow-up to Jeff's question, and then I think also a clarification from Boyd. We're getting a couple more questions. So why don't we start with the follow-up to Jeff's question from Nate Campbell.
Hey, it wasn't necessarily as much of a question as just do you offer a tilt only window for Jeff instead of a tilt turn?
Oh yeah. Yep.
Maybe that's a solution for him.
Yeah, no, thanks. Sounds like the turn function though is what he's looking for, but yeah, totally. That is very common, a tilt only window. Yeah.
A lot of second floor bedrooms.
Yeah.
Mm-hmm.
Yeah.
All right, great. Thanks, Nate.
And also, I do have a quick follow-up question, completely separate. I came in a little late and I wanted to understand what's the makeup of your 52 millimeter IGU?
Well, it would depend on the size. It's a triple glazed unit. Glass thickness would depend on the size of the unit itself, whether it's a 444 or a 545 or whatever it would be specific to the size. Yeah.
Right. And I guess I was wondering what's your spacer size on that?
So it could be up to we can go up to a 3/4 inch spacer, and it's the same Pascal certified spacer, the Tri-Seal super spacer. So as Davyd said, every IGU is going to have a different makeup, so different glass thicknesses would depend.
It's all unit specific. Yeah, like we've done. You think of the combination, we've probably done it.
Yep. Thank you.
No problem.
Great. Thanks, Nate. Okay, so Boyd's follow-up on the tilt turn question was looking for a tilt turn in uPVC that competes on price with the uPVC products of other European manufacturers.
Yeah, I think the Rough ePro product does that. I'd be open to obviously we're open to quoting things and looking at them. It's a very competitive product. We've been manufacturing it for some time. We've got it kind of dialed in. So, I mean, yeah. So it's sort of like, it's a triple gasket system. When you look at Rayhow or other manufacturers, there are uPVC tilt and turn windows, but they don't have all the merits that I just explained, right? So it's kind of like you have to pick a line. So we've tried to specialize in what we think is going to fit the broadest part of the performance market.
Great. Thank you. All right. And Joshua has a question about lifespan of low E coatings.
Yeah, and I don't know if there's any basis for this. I just had a couple of people reach out to me asking me about low E coating deterioration over time. I would assume that it doesn't deteriorate, but couldn't find any information for or against anywhere. So just wanted to ask
Yeah, so
the pros.
Yeah, like our counter to that would be, you know, our glass manufacturer will warrant, and so will we, for 25 years, right? Any defects in the IGU. So at that level of time frame, if you see deterioration, then, you know, we're going to replace it. So I think it's kind of like we put our word on it.
No, I get that. I guess the question is, has anyone been testing or checking the performance of that low E coating? Because obviously you're not, unless it's kind of turning silvery or whatever, we're probably not noticing it as a client. But I think it's more the question of the actual performance over time. I just haven't seen any data either way. That's why I was kind of curious.
I'm not aware. Alfred,
I think it would have a lot to do with the initial quality of the glass from your glass supplier. If you're getting it with a glass supplier like we do, then you're gonna have a proven product. Like by our supplier, our IGUs are built by PFG and Langley. Glass is from Cardinal. That's historically been a very consistent and long-lasting system.
Yeah, makes sense.
You know where you're getting it from.
after this, I'm going to ask my manufacturer though, see if he's heard anything. Yeah.
If you learn anything, maybe just shoot me a note, because yeah, I'd love to be able to just say no. We know that the low E coating lasts. That's my expectation, but I just love to see that.
There's a comment in the chat there from Terry from Fen Canada, and he would know. And he says, no.
Awesome, thanks, Terry. Yeah, it makes sense. As long as the seal stays intact, it's not going to get affected.
Yeah. Yeah.
Great.
Thank you.
We absolutely, Joshua. We've got some more questions. I got one DM to me from Mike Lind. I think, Mike, I'll just, unless you want to come on, I can ask it for you. So this is for David. Can the 56 millimeter frame used on your door be used in a window to reduce the sight line? And do you have foam inserts for those?
You're talking about the low sill. The answer is, yeah, we do make picture windows out of that low sill for just that reason. And this is getting maybe even more complicated than we need to, but the depth of that profile matches up with our casement window and or with our 4700 tilt and turn window. So you can interchange to achieve architectural looks as needed. And can you put foam in it? Yes, you can. Yeah.
Excellent. Thank you. Yep. Thanks, Mike. And then Sandra, great observation. Do you want to share that?
Oh, yeah, I can. I'm just wondering, somebody asked the question on the format of the window related to the turn, and then David said that obviously the format that's wider than higher might be sagging in the hinges, and it obviously always be, unless the window is very small. But if the question was related to having the window turn just for the purpose of cleaning it on the exterior, there's always the option of having a turn and tilt or tilt and turn window, and then locking the turn function for day-to-day operation, right? Yep. That would be one way of going for it without having it fail, because it will be sagging over time potentially.
Yeah, no, absolutely, Sandra. Thanks for that additional clarification. Yeah, these are some of the things we would suggest, you know, once we understand what you want the window for. I guess the thing about that and some of the other things we've expressed here, we try to be realists, right? We want to do things, but we also want to explain what's going to work, what's our experience. Being at it for 30 years, our building is filled with a lot of experience. And it was great to hear, you know, Joshua comment on that. I think I'm very proud of that. I know everyone here is. And so we're happy to try things, but we'll tell you what our thoughts are first, and we won't sugarcoat it.
Oh,
Yeah.
and since I'm on the mic right now, I would like to add to that it's great, having worked with Euroline before, to have experienced passive house window manufacturers on board. They should really become part of the planning team, if possible.
Thank you.
That's all I have to say. Yeah.
We'd love to
Yeah.
have more input in the
Yeah.
planning.
Yeah, no, it's honestly, it's a lifesaver. It's what Alfred's comment there earlier on, well, they decided to steel frame the balconies, and we had to add more insulation, and I'm not going to comment more on that. It was great. Like, you only get that comment from somebody that understands passive house, right?
Yep.
Thank you, Sandra. David and Alfred, that seems like a pretty darn good place to wrap things up here. So before we do, is there anything else you want to add before we close out?
No.
Yeah, you're good.
This has been great. Thanks everyone for your questions too.
It has been great. And yeah, I do want to thank everybody in the audience for being here and for the great conversation. And Alfred and David, a fantastic presentation and great information during this discussion. Really appreciate that. And also a big thank you to Euroline Windows for your support of House Accelerator and the work that we do. It means a lot to us. Great. Thanks so much, everybody. Be well.
Bye, everyone. Thanks.
Thanks a lot.